neutrons, atoms, molecules, elements, organisms, civilizations, moon, planets, solar systems, galaxies, black holes, cosmos.
What's up, Javon?
Oh yes, Professor Pratt, I had a question on ellipse of Earth and how it revolves around the sun.
Let's take a look. Alright, you can have a seat. We'll start on the problem.
Alright.
So what an ellipse is, it's a 2D shape created by the intersection of a plane on a double right cone, defined by 2 points known as a foci. So I'll draw that out for you. So an ellipse isn't a circle per se, it's more of an oblong shape. So the 2 foci points can be located here. And what it states is that the distance between these 2 points to any point on this ellipse are always constant. So from here to here will be the same if it was going from here to here, all the way around to any point on this ellipse. Okay? Now for the sake of this problem, we'll have the ellipse run on either the y-axis or it'll either run on the x-axis. Alright? And much like the Pythagorean theorem, the length of an ellipse can be found using the equation b squared plus c squared equals a squared. What b squared stands for is the length of the minor axis. So the minor axis depends on which type of ellipse you have. If it's a horizontal, this is the b right here. If it's on the vertical, this is the b. The a is the length of the long axis, which is here, and for here is running along the vertical. And then your c is the distance of your foci points. So usually the foci points will run along the a as well, but it won't be as long. Same thing for here, it'll run along, but it's a lot shorter. And usually in the equation with an ellipse, you'll be giving either 2 of these points, so you can plug them in and figure out the length of the other. Alright, for the sake of this problem, we're looking for, let me erase this. We're looking for the size of the major and minor axis of the Earth's ellipse as it revolves around the sun. So we're looking for what A is and what B is. Before we can begin that, I have to give you the equation of the general ellipse. So that is x squared over a squared plus y squared over b squared 1. Now these two values can switch depending on which way the ellipse runs. If it's a vertical, the y will be first. If it's a horizontal, the x will go first. These two bottom values, they never change. They will always be the same, a squared and over b squared, because a is always the biggest number and b is the smallest number. So from the problem you gave me, it says that a is unknown and b equals 10,000 miles. So now, for us to find this point A, the length of it, we should also know C, which was given. C equals 8,000 miles. So if you were to plug that back into your equation, the original, we know B, 10,000 units squared, plus C, 8,000. B squared equals A squared. So now that we figured that out, you can do that with your calculator. Tell me what the values are.
Oh, I got it.
What is it?
It is 64 million.
For which one?
For 8,000.
64. And what about for the other one?
100 million.
Alright, now that you have these two values, you will add them together to get 164 million equals A squared. Now the inverse operation of squaring a number is square root. So you square root both sides. A should equal, what is it, Javon?
404,969.
Alright, so now we know what furthest point of the Earth will ever be from the Sun, which is right here, which is 404,969 miles. So now that you know this, you can plug it into your original ellipse equation. So this is a vertical ellipse, so of course your y goes first. For the sake of this problem, we would say that the center is at 0, 0, so it is left the same. We know your A, which is 404,969, squared, which is 164 million, plus your x squared, since the point is 0, 0, and then you know your b is 10,000 squared, which is 100 million. And of course, this equation always equals 1. And there you go.
Mr. Pratt?
No problem. Let me know if you have any other questions. I'm always here to help.
Will do.
But wait, there's more. This video is provided by FIFA, the worldwide leader in soccer.